Good day, learners! I'm Teacher JC, your mathematics teacher on the go. Once again, I'm Teacher JC and welcome to another lesson full of fun and learning. So what are you waiting for? Get ready for note-taking for we are about to start. Are you ready? Then let's get started. And welcome to
Tutorial.
Mathematics 7, Quarter 3, Module 4. Our most essential learning competency illustrates polygons by A. Convexity, B. Angles, and C. Sides. At the end of this lesson, you are expected to define, identify, and illustrate the different kinds of polygons according to the number of sides. Identify the parts of a regular polygon, interior, exterior, and the points on the polygon itself. Differentiate convex from concave or non-convex polygons. And lastly, determine the sum of the measures of the interior and exterior angles of a polygon. The polygons. A polygon is a plane figure described by a closed polygonal line. To understand what that means, watch this straight line become a polygonal line as it forms several sides which eventually close. And what do you see? A polygon. Easy, right? In fact, in Greek, the word polygon literally means many sides. Look at these shapes. Can you see a polygon? I'll give you 5 seconds to identify the polygon. Let's see if your answer is correct. Let's have the first one. The first shape is not a polygon because its polygonal line is not closed. The second shape is not a polygon either because it has a curved side. Oh yes, that's it, you're right. The third shape is a polygon because it's formed by a closed polygonal line. Easy, right?
Huh?
How about this picture? Can you spot polygons? I'll give you 10 seconds to find them. Timer starts now. Save your answers for now and let's check it later. A polygon is made of several parts. The sides are each of the lines or segments that form the polygon. Here we have pentagon COVID. The sides are segments CO, OV, VI, ID, and DC. The vertices are the points where all sides meet. The vertices are points C, O, V, I, and D. The angles are the space determined between two adjacent sides that meet at a common vertex. These two sides form an angle VID. In this case, the angles are 1, 2, 3, 4, and 5. Thus, the angles inside are called the interior angles. Let's extend the sides in one direction. The angles formed outside are called the exterior angles. The diagonals are the segments that connect two non-adjacent vertices. The diagonals are segments DO, CV, CI, DV, and IO. We can classify them in different ways: regular or irregular, convex or concave, and depending on the number of their sides. The first classification we can make is if they are regular or irregular polygons. A regular polygon has all sides and angles equal. These two other polygons are regular. The sides and the angles are the same. On the other hand, an irregular polygon does not have all sides, nor all angles are equal. These polygons are irregular too, because their sides and angles are not equal. Here you can see some examples of regular and irregular polygons. Polygons can also be classified as convex or concave. A convex polygon has all interior angles less than 180 degrees. All its diagonals lie entirely inside the polygon. On the other hand, a concave or non-convex polygon has at least one diagonal with points outside the polygon. As shown in the illustration, one diagonal is outside the polygon. It is a concave polygon if and only if at least one of its interior angles is greater than 180 degrees. As you can see, one angle is greater than 180 degrees. That makes it a concave polygon. Another way to classify polygons is by the number of sides they have. These are the kinds of polygon according to the number of sides. Let's have the first one. Triangles are those polygons that have three sides. This slice of watermelon has a triangular shape. Quadrilaterals have four sides. This kite and this table are quadrilaterals. Pentagons have five sides. This doghouse and spot in soccer ball have the shape of a pentagon. Hexagons have six sides. These potato chips and honeycomb cells have the shape of a hexagon. There are many types of polygons, but to learn how to read them, you need to use the corresponding prefix. It is very easy. A seven-sided polygon is a heptagon. An eight-sided polygon, an octagon. A nine-sided polygon is a nonagon. How about a 10-sided polygon? A decagon. And so on. N-sided polygon is n-gon. So these are the different types of polygons according to their number of sides. Those geometric shapes can be found everywhere. And now let's talk about the picture I've shown you a while ago. Can you see now any polygon? Wow, excellent! All these objects are polygons. Like math, polygons are everywhere. You only need to look around you and pay close attention. Let's find the total interior angles of the following polygons. First, the total interior angle of a triangle. Using the angle sum theorem, the sum of the measures of all interior angles of a triangle is 180 degrees. Similarly, we may find the sum of the measures of the interior angles of any polygon by dividing the polygon into triangles. To do so, we need to use diagonals, but make sure that the diagonals do not intersect each other. In this case, we only have one diagonal. Since a triangle has a total interior angle of 180 degrees, then we multiply 2 by 180 degrees. Therefore, the total interior angle of a quadrilateral is 360 degrees. Next is the pentagon. In this case, we form 3 triangles. Each triangle has a total interior angle of 180 degrees. Therefore, 3 times 180 degrees is equal to 540 degrees. In hexagon, we have 4 triangles times 180 degrees, so the total interior angle is 720 degrees. In heptagon, we form 5 triangles times 180 degrees, so the total interior angle of heptagon is 900 degrees. How about the total interior angle of an octagon? We have 6 triangles times 180 degrees equals 1080 degrees. Observe the following examples. Can you see a relationship between the number of sides and the number of triangles made in the polygon? Great! Nice ideas! To find the sum of the angles in n-sided polygon, take 2 away from the number of sides and multiply by 180 degrees. So, S is equal to n minus 2 multiplied by 180 degrees, where S is the sum of the interiors while n is the number of sides. While the total exterior angles in n-sided polygon will always equal to 360 degrees, meaning all polygons have a total exterior angle of 360 degrees. A polygon is regular if and only if it is convex, equilateral, meaning all sides are equal, and lastly, equiangular, meaning all angles are equal. To find the measure of each interior angle in polygon, divide the total of the angles by the number of sides. So we have n minus 2 times 180 degrees divided by n, where n is the number of sides. On the other hand, to find the measure of each exterior angle in polygon, we have 180 degrees minus the interior angle. Sample number 1. Find the sum of the measures of the interior angles of an octagon. For the solution, we will be using the formula S is equal to the quantity n minus 2 multiplied by 180 degrees, where the given n is equal to 8 because an octagon has 8 sides. Then substitute the value of n. 8 minus 2 multiplied by 180 degrees. Then 8 minus 2 is equal to 6 multiplied by 180 degrees. So the total interior angle of an octagon is equal to 1080 degrees. Now let's have example number 2. Find the measure of each interior angle of a regular nonagon. For the solution, we will be using the formula S is equal to n minus 2 multiplied by 180 degrees, where the given n is equal to 9 because we have the nonagon which has 9 sides. Then substitute the value of n. We have 9 minus 2 multiplied by 180 degrees, and 9 minus 2 is equal to 7 multiplied by 180 degrees. Therefore, the total interior angle of a nonagon is equal to 1260 degrees. To find the measure of each interior angle, divide the total interior angle S to the number of sides n. S is equal to 1260 and n is equal to 9, so therefore 1260 divided by 9 is equal to 140 degrees. So the measure of interior angle of a regular nonagon is equal to 140 degrees. Now let's have example number 3. The sum of the measures of the interior angles of a polygon is 1440 degrees. How many sides does the polygon have? For the solution, we'll still be using the formula S is equal to the quantity n minus 2 multiplied by 180 degrees, where the given sum is equal to 1440 degrees. Let's substitute. 1440 degrees is equal to the quantity n minus 2 multiplied by 180 degrees. Then divide both sides by 180 degrees. And 1440 degrees divided by 180 degrees, we have 8. Then, add both sides by 2. Then n is equal to 10. Therefore, the polygon has 10 sides, meaning it is a decagon. Now let's have example number 4. How many diagonals does a 63-sided convex polygon have? For the solution, we'll be using the formula n multiplied by the quantity n minus 3 all over 2, where n is equal to 63. Then let's substitute. 63 times 63 minus 3 all over 2, and 63 minus 3 is equal to 60 multiplied by 63 all over 2. So we have 3780 divided by 2 is equal to 1890. Therefore, the polygon has 1890 diagonals. The exterior angle theorem. The measure of an exterior angle of a triangle is equal to the sum of the measures of the two opposite interior angles, also referred to as remote interior angles. In this illustration, the measure of exterior angle D is equal to the measure of angle A plus the measure of angle B. Solve for x and D. Here's the solution. To solve for x, we're going to use the angle sum theorem, wherein the sum of the measures of all interior angles of a triangle is equal to 180 degrees. Therefore, x plus 51 degrees plus 42 degrees is equal to 180 degrees. Got it? Excellent. Now let's continue. 51 degrees plus 42 degrees is equal to 93 degrees. Then, subtract both sides of the equation by 93 degrees. And 180 degrees minus 93 degrees is equal to 87 degrees. So the value of x is equal to 87 degrees. And now, let's solve for D. Using the exterior angle theorem, the measure of the exterior angle of a triangle is equal to the sum of the measures of the two opposite interior angles of a triangle. Therefore, D is equal to 51 degrees plus x. Got it? Good. Now let's continue. Substitute the value of x, which is 87 degrees, so we have 51 degrees plus 87 degrees is equal to 138 degrees. So D is equal to 138 degrees. Can you do this? Solve for x. In this given example, x is the remote exterior angle and is equal to the sum of the measures of the two opposite interior angles. So, x is equal to 64 degrees plus 45 degrees. And the sum is 109 degrees. Therefore, the exterior angle is equal to 109 degrees. How about this given problem? Solve for x. So for the solution, still we'll be using the exterior angle theorem, wherein the measure of an exterior angle of a triangle is equal to the sum of the measures of the two opposite interior angles. So 3x minus 10 is equal to x plus 15 plus 65. And 15 plus 65 is equal to 80. So therefore, we have 3x minus 10 is equal to x plus 80. Then, combining like terms, 3x minus x is equal to 80 plus 10. And 3x minus x is equal to 2x. And 80 plus 10 is equal to 90. Then, dividing both sides by 2. And x is equal to 90 divided by 2 is equal to 45. Therefore, x is equal to 45. Seems like you are now ready to do the task on your own. Now it's your time to shine. Get a piece of paper and do the following exercises on your modular printed materials. But I'll be showing you the activity in the next 5 slides. So pause the video in every slide to copy. Ready? Let's go! At this moment, pause the video and answer that in 10 minutes. Start answering and resume the video when you're done for the key answer of this activity. Good luck! Here is the key answer of the activity. Let's start. Nice! You did a great job. Excellent. Since it's very easy for you, then answer the following. Get another piece of paper and answer the assessment on your modular printed materials. But I'll be showing you the activity in the next slides. So if you want to copy it here, just pause the video in every slide. Are you ready? Let's go! At this moment, pause the video and answer that in 10 minutes. Start answering and resume the video when you're done for the key answer of this assessment. Good luck! Here is the key answer of the assessment. Let's start! I hope you enjoyed and learned something today. Once again, I'm your math teacher buddy, Teacher JC says, Math It's So Easy with Sir JC. Bye-bye!